looked at the standard form of a circle, and it allows us to quickly unpack it to graph a circle in a few short steps. What we learned was the x value for the center is the opposite sign of this spot, positive 4, and the y value is the opposite sign of this position, which would be negative 4. Then we have our radius squared, so in order to know how long the radius is, we would square root it. And the square root of 16 is 4. This is extremely quick and simple, but we're not always going to have our squares in perfect order like this. You might see something like this, and we need to understand that this is actually the same thing. So if I had given you this bottom equation, you would have a harder time finding the center and radius so quickly, especially since they tend to take the negative 16 and subtract them on both sides. So the numbers might be on one side and the variables would be on another. In order to do these equations, they become very quick and are not that difficult. And again, they're used in Algebra 2, they're used in math beyond that, so they're very important and to me a fun part of algebra. It just makes you feel so smart because it seems so complicated, even though it's not. So understanding factoring and how squares work, perfect squares, will help us to do this very quickly. So you want to take some time for a few examples of factoring and perfect squares, and reverse, distributing, and packing and unpacking the same equation. If you already know how to do this, I'll put in the notes, the video notes, what time you can skip to so you can skip ahead. What we learned about squares is that a perfect square is talking about an actual square. So if we have an area of a square, it's length times width, and we know that the sides are the same. So if I said if the area of a square is 16, what is the root of the sides? What is one of the sides? It would be 4 and 4. So the square root of 16 is 4. Well, the root of 9 would be 3 and 3. So the square root of 9 is 3. And the reverse, 3 squared, a square with sides 3 would make 9 units in between if we were using actual shapes. So squares really are referring to real squares and shapes, but as we get into very complex and large squares and algebraic squares, we're using and compressing a whole lot of information and solving into short processes, even though they seem like a lot of work to us. So what we want to look at is, well, what if we have little knowledge of the sides and it's x plus 3 and x plus 3? Well, we want to practice then making perfect squares and factoring perfect squares when we have algebraic expressions. So let's take that one. X plus 3 times x plus 3 is what we're looking to convert into the following, x plus 3 squared. What we learned was a square is the same number or variables or combination multiplied by itself. So there's two of them. If I had a third one, there would be to the third power. What we want to take a look at is what happens when we multiply this out and distribute it. We can FOIL. We learn first, outside, inside, last. Basically, we're doing a multiplication to each combination. So x times x would be x squared, and then x times 3 would be 3x. So we're multiplying the first x to both of the other terms in the second part of the multiplication. Now we're going to take the number 3 and multiply times x, so we get another 3x. Then 3 times 3 is 9. What we have here is going to be very, very valuable to quickly understanding how to complete the square. There are a few things to point out, and we'll do another example. Where does this whole number come from? Well, it comes from this times this, 3 times 3. So we can actually look right here and find it. 3 squared is 9. Where does this come from, the 3x and the 3x? When we add them, we're going to get 6x. So if we started with 3, how did it turn into 6? Well, because we're distributing it twice. First, we're saying the x times 3, then over here, 3 times x. This is going to help us to understand that when we do a perfect square, we can make a shortcut. I know it's going to be x squared because it's going to be x times x. I know the end is going to be 9 because 3 squared is 9. And I know that the middle term will be 3 times x twice, so 6x. So we'll get the same answer, but it'll be a little bit of a shorter way to do it. Let's take a look at another one. If we have x minus 2 times x minus 2, that's x minus 2 squared. We're going to multiply x times x is x squared. We know the final term is going to be negative 2 times negative 2. So we know the final term is going to be 4. And we know the middle term is going to be whatever is there, negative 2 times x, twice. Twice, negative 2 times 2 is negative 4. So we do keep the sign. So let's see when we FOIL how we got the same answer. X times x is x squared. X times negative 2 is negative 2x. Then we take the second term, negative 2 times x is negative 2x again. And negative 2 times negative 2 is positive 4. So what we have here is the same thing we can find if we use the patterns we see in the previous two examples. So the reverse is true. I can take this, apologize for the silence, I can take this and unpack it, right? If I want to turn this into a perfect square, I know it's going to be x times x to give us x squared. I know there's going to be 2 times 2 to make the 4 at the end. This one. The only other thing is I need to check the sign. So 2 times 2 makes 4, but so does negative 2 times negative 2 makes 4. So when I add them in to get the center, I can see it's going to be negative 2x and negative 2x. So I want to make it negative. So this sign here ends up here. The last term will always be positive because we're squaring it. Negative 2 times negative 2. So this is a little bit of practice looking at how to factor and even put back together some perfect squares. And we'll do one more example, and then we'll get into how to complete the square, which is what the main goal is here. So let's take x squared plus 18x plus 81. And it's a little bit of bigger number. We know we're going to have x times x, and we know that a number times itself is going to be 81, so I'll square root this. I'll get 9 and 9. Then I'll just check the sign, and it's positive. And let's check it. X times x is x squared. X times 9 is 9x. 9 times x is 9x again. And 9 times 9 is 81. X squared plus 18x plus 81. Now we can even do this with a fraction. It's just something you need to be a little bit more careful with. We can take x squared plus 1x plus 1/4. And right, we can take the same idea. We're going to have x and x. Well, what's the square root of 1/4? Square root of 1/4 is the same as square root of 1 over square root of 4, which is 1/2. So we know it's going to be 1/2. And let's just check that. X times x is x squared. X times half is half x. half times x is half x again, and a half times a half, we multiply straight across. 1/2 times 1/2, straightforward. 1 times 1 is 1, 2 times 2 is 4, plus 1/4. You see, we're going to have half plus half is a whole, that's what we have here. X times x is x squared, and then half times half is 1/4. So we got the same thing that we started with. This is just playing around. So we're going to use this concept and this idea of a perfect square to complete the square. And we can take a problem, I can take a couple from the internet here, and we can practice it. So when we get into the equation of a circle in general form, we're going to be completing the square twice. And maybe I'll do this video as an introduction to completing the square and to being prepared to do the general form, but then the second video will be actually doing the general form itself. So if we look at completing the square, we have a couple of problems here we can look at. So when we're completing the square, if it makes you more comfortable, you can turn this into an x. Sometimes students aren't as familiar. X can be really any variable. The first thing we want to do is we're going to move the whole numbers over. So we want to deal with just the variables on one side. So I'm going to add 38 to both sides of the equal sign. So we have really x squared plus 14x, and then I'll leave a space here, equals 38. Well, from what we've looked at so far, we want to figure out what number will we have to put here in order to make a perfect square, and we'll add the same number here, because by making the perfect square, we're adding something here. This is not a perfect square yet. We're turning it into one. And once we have that number, we can pack it into the perfect square and get our center and radius if we were graphing a circle. So let's think about what we said. We said it's going to be x times x, and then we have this number twice, right? It's going to be 7x plus 7x. So we know the number is going to be 7. So what would we have as the final number here? Well, if we remember what we practiced, it's going to look like this, the perfect square. So it's going to be 7x plus 7x, which gives us the 14. But then the end will have 7 times 7, or 49. So we're really going to put a 49 here if we make a perfect square. And we're going to add the same thing here. Now, I do things a little bit differently because I get to the perfect square and then I go back and I'm going to put these numbers in here. So let me show you the way I do it, because to me it was an easier process to begin to understand completing the square when I was learning it myself. So here's what I say. First, we're going to make our perfect square. We're going to say x plus and then something squared. We know that number is going to be half. So we're going to take half, and I'll give some notes on this in a moment. We're going to take half of that number, which is 7. So this is our perfect square. I'm kind of a step ahead. Now I need to go back and add what whole number I need to put in this position to end up getting the perfect square. So I'm going to take 7 squared. That's what's going to go right there. 7 times 7 is 49. So I'm going to add 49 to this side as well. And that's it. So 38 plus 49 is 87. And that's our perfect square. So our final answer is x plus 7 squared we have it packed in a perfect square, equals 87. So what did we do there? And let's look at another example. So the first thing is we start with a equation like this. Well, typically they say this, but we're not using a number in front. Ax squared plus bx. We're not using a number in front of the x squared. We could. We'd have to divide everything, but that's getting a little ahead of where we're at so far. So what did we do? Well, we said we pack it into a perfect square. We know x is in the front. And we need to figure out what goes in this position. And when we square it, it gives us our whole number, or letter C. Well, the way that we get it is we divide the middle one, the one where x is, in half. So we're always going to divide that middle term by 2. So if we use a variable here, we're going to take b over 2. And then to get the letter C, I was showing you we square it. We're going to square whatever's there. So this is with some variables. Let's look at a real number. Well, let's look at this one. X squared minus 12x equals negative 11. So I've prepared by subtracting 11 on both sides. To make my perfect square, I'm going to put x minus something squared. So because of the minus, I know it's going to be minus. So I want to get my perfect square, then go back and put the whole number in this position that we have to then add to both sides, because by making this perfect square, we're including a number that's not there. So that's why we have to add it to the other side. The way we would find the number that goes in the position we're looking for is we would take the middle term and divide it by 2. So negative 12 divided by 2 is negative 6. So that's our perfect square. We're done with the perfect square part. We only need to go back to add to both sides the number we ended up including. So I'll explain that in a moment if you wanted to understand a little bit more about what I'm saying. So the number that's going to go in this position will always be the last number, the whole number squared. So I'm going to take this, negative 6 times negative 6, and that gives me 36. So I'm going to add 36 to this side as well. I don't need to do anything with this number. It's already included right here. But I do need to add it on the right side. So 36 minus 11 is 25. And that would be my answer. I've completed the square, but I made sure to add to the right side what I included, the 36. And I included it as a part of my perfect square. Because let's unpack this and see what we were saying earlier, how it's going to be x minus 6 times x minus 6, which gives us x times x is x squared, x times negative 6 is negative 6x, negative 6 times x is negative 6x, and negative 6 times negative 6 is 36. So you see, there are a few things we started with, but there are a few things that we added. We added the 36. We started with this problem with x squared. Here it is. We started this problem with negative 12x, and here it is, the negative 6 and negative 6. But we didn't have a 36. So by making this perfect square, I'm adding 36 to this side. So by doing that, I have to do it to the other side. And that's why we have to add 36 to the right side. It's not even necessary to know why, but that's a little explanation of why you have to add the 36 to the right side. And you are adding it to the left, but you're not really seeing it because it's turning into a perfect square. So let's take another example and see if you can get it. I'm going to take x squared plus 6x equals 59. I added 59 to both sides. I move over my whole number. Then I want my perfect square. So to get my perfect square, I'm going to get half of this, which is 3. Now I, by doing that, added 3 squared here. So I have to add it to the other side. So 3 times 3 is 9. I need to add 9 to this side. And this is my perfect square. So these are the concepts we are going to use in order to rearrange the general form and be able to graph a circle. So let's talk about these steps one last time, maybe with a little bit of explanation. We're going to take something like this. First step is going to be, we're going to move over the whole number. So I'm going to add 4 to both sides. And I now have x squared plus 6x. Our second step will be, I'll use another color. The second step is going to get half of the middle term to get our perfect square. So we're going to get half of 6x. X plus something squared. So to get that number here, we're going to get half of 6 is 3. Then we're going to add the 3 squared to both sides. So 3 times 3, or 3 squared, is 9. I need to add it to this side. So I don't do anything with my perfect square. We put the 9 here because it's included in this perfect square. But this side I do need to add, and it will be 13. And that will be my final answer. So that is how to complete the square. We'll have another video for how to do the general form, but here's a quick example. Let's take the ending here and repack it. So I'm going to take these, but put the x squareds next to each other and the x next to it. I'm going to then put the y squared and the y value next to it. And then the whole number, I will then add it to the other side. So I'm going to add 4 to both sides. And I'm going to leave a little bit of room. So what we're going to do here is we're going to complete the square for this one and then do the same thing for this one. So I'm going to take x squared minus 4x, leave a space, y squared plus 2y, leave a space, equals 4. So essentially we're going to complete the square for this one and then add to both sides, complete the square for the y and add to both sides, and we'll have everything in the right form. So in order to do that, I'm going to take x something squared. I'm going to take half of this, becomes negative 2. So the number I'm putting here is negative 2 squared, or 4. And I'll add that to the other side. The same thing will occur here. There is a plus in between them, just like there was here. So I'm going to say it's y something squared, my perfect square. I'm going to take half of this, which is 1. And then add something to both sides. I'm going to add 1 squared, or 1 to both sides. So now we have this perfectly done in the standard equation. We know our center will be the opposite sign, 2, negative 1. And our radius squared is 9, so our radius is 3 when we square root it. Now we can graph this circle. So I hope this helps some of you. Please let me know if you have any questions.